In this video, I want to sketch the graph of the plane curve generated by these parametric equations. X is 5 times the quantity of t minus sine t, y equals 5 times the quantity of 1 minus cosine t, and t is between 0 and 2 pi. Well, what I really want to do is use my graphing calculator to get a good sketch, but in the end I am going to want to be able to draw that good sketch. But my graphing calculator is going to help me a lot here. The first thing we need to do is put our calculators in parametric mode. What I see here are 3 options. Function, and that's what we're probably used to, where when I hit the y equals button, it literally says y equals. Excuse me. Then there's the parametric mode, where now I can see I've already entered in these 2 parametric equations. But then there are 2 more. There's a polar mode and a sequence mode. All right, well, we're in the right one right now. We're in parametric mode, and I'm going to enter that first equation in again. I have 5 times t, and notice I hit the variable button the same way I used to use for x, and see across it I have x, t, theta, and n. Those correspond to the different modes in the calculator. That's not an x button, it's a variable button. All right, so I have my equations entered in now. I'm just going to hit graph. And I don't feel like I get a good graph. I don't feel like I see enough of the graph. It kind of like goes off the screen. So I want to talk about how to find good values for my x-axis and y-axis, and then we're going to change what's in the window. Now what's nice is the calculator was already setting up the graph from 0 to 2 pi. So let's look at the x and think about the largest and smallest things I might have to deal with. When t is equal to 0, well, I get out x is 0. But when I plug in 2 pi, I get out that x is 10 pi. So I'm at least going to need x's between 0 and 2 pi. And it's not too hard to realize that that's the largest value I'll need. On the y-axis, if I plug in a 0, well, I'll get out a 0. If I plug in a 2 pi, I'll also get out a 0. But if t is 1 pi, that makes cosine a negative 1, and I'll get out the number 10. So on the y-axis, I'll need things between 0 and 10. So now my calculator, I'm just going to change my x min and my x max. And do you know what? Since I have, I'm counting by pi's here, I'm going to count by pi's here. On the y-axis, I can start at 0, and I'll end at 10, and I think that's okay to still just count by ones. I'm going to hit the graph button, and now I see the whole graph. Stretched funny, right? I'm not in a good aspect ratio anymore, but I understand what's going on. I go through these points, and I rise and fall. And I don't think that's steep enough. There we go, that's better. And of course, if I wanted to graph this more accurately, I'd plot more points. And one of the cool things that happened, I'm gonna just pretend I'm changing the window a little bit. The calculator graphs it out in the increasing order of t. Well, it's not gonna do it now because I didn't change anything, so I'm just gonna make this say be 6.3, pretty close to 2 pi, a little more than 2 pi. But see, it's tracing it out in the increasing order of t, so I even know the orientation. Of course, if I was concerned about that, I could actually plug in some values of t and see that as well. But there I have it. That's how we can use our graphing calculators to get a very good sketch of a parametrically defined plane curve.